Hi, this is Alex from devstories.eu. LangGraph, Episode 8 of 18. You cannot hardcode your execution paths when you have no idea how many subtasks your agent will decide to create until it actually runs. If your system decides on the fly that it needs to process 3 items or 30 items, standard static routing will fail. To fix this, you need MapReduce workflows with the Send API. A very common mistake when building in LangGraph is trying to use standard conditional edges for dynamic fan-out. Conditional edges are perfect when you want to choose between known, predetermined paths based on a logic check. However, they fall apart when you need to spawn an unknown number of identical parallel tasks at runtime. Standard parallelization allows you to route to fixed multiple nodes. You name the nodes and the graph triggers them. But what happens when you need to run the exact same node multiple times simultaneously, each with a different piece of data? You cannot do this with basic routing. This brings us to the Orchestrator-Worker pattern. In this architecture, a central node looks at the incoming data, calculates how many separate tasks are required, and dispatches dynamic workers to handle them concurrently. LangGraph enables this pattern specifically through the Send API. Consider an agent tasked with writing a comprehensive research report. The first node acts as the orchestrator. It reads the user prompt and generates an outline. Depending on the complexity of the topic, this outline might contain 3 sections, or it might contain 12. You want a separate worker node to draft each section at the exact same time. To achieve this, you define a conditional edge function immediately following your orchestrator node. Instead of returning a simple string that points to the next static node in the graph, this edge function returns a list of send objects. Here is the key insight. A send object packages a destination and its data together. It takes 2 arguments. The first argument is the name of the worker node you want to trigger. The second is the specific payload for that isolated worker. In our report scenario, the orchestrator function iterates through the generated outline. For every section topic it finds, it creates a new send object pointing to a single node called draft section, passing the individual topic string as the payload. When LangGraph evaluates this edge function, it receives the list of send objects. It then dynamically spins up a parallel instance of the draft section node for every single item in that list. If the orchestrator generated an outline with 7 sections, LangGraph launches 7 parallel drafting nodes. Each node runs identical code but operates on its own unique payload. Generating these dynamic workers is the map phase. Gathering their independent outputs is the reduce phase. Because these worker nodes run concurrently, they cannot safely overwrite a single string in your graph state. Your overall state must be configured to collect multiple incoming updates simultaneously. You handle this by attaching a reducer function to the specific state field that will hold your drafted sections, instructing it to append new items to a list rather than overwriting the previous value. As each parallel draft worker finishes writing, it returns its text block. LangGraph catches these responses and uses your reducer to safely stack each text block into the shared array. Once every dynamic worker completes its execution, the entire parallel step resolves. The workflow then moves forward, carrying a complete populated list of all drafted sections. The Send API takes parallel execution out of your static graph definition and puts it directly in the hands of your runtime data. Thanks for hanging out. Hope you picked up something new.